Now you might have thought that 5.1, that wasn't too bad. That was a good warm-up, because now we're going to get into it a little bit more in detail, where we're going to use the power rule for exponents and then continue with our objectives. Now, when we're using the power rule, as we see here, and let's say we're saying the sides of a cube were x squared, that was the length of each side, and there's one up there, and then there would be this, that would be the height, that would be this side, and there would be this side. So you would have length times width times height, so you would have x squared raised to the third power. Now if you wrote it out this way, you would just add these up and you would get 6. But is there a way to do it just from there without having to expand it? And you might say, yes. How would I get from this to x to the 6 from there? And you would say we would just multiply. Now, that is the power rule. When you have something in the parentheses with an exponent, and now you're raising that to an exponent, that's the power rule. This is when we multiply. Now, when it's in this form, we're just adding the exponents. Now remember, multiplication is a shortcut over addition. Okay, so we're looking now at the power rule in a number of different forms. Raising a power to a power, because of the parentheses, we multiply. And then if there is no exponent on what we have inside, remember there's a 1 by each of the letters, so that this becomes this. And if we have a parenthesis with a fraction in it, that n applies to each of the numerator and denominator. And we are recalling that b cannot be a 0, because we can't have that rule for 0. Okay, so for example 1, this is the power rule. So we're going to multiply x to the 35th power. Now I can't tell you how many students have done this incorrectly and said it was 12, x to the 12th. No, that's wrong. Because what you have here is you're writing this base 5 times. So you're adding that 7, that 5 up 7 times. 5 times 7 is 35. And they do want us to simplify if we can. So this will be 2 to the 6th power, which is 64. Now, again, we're multiplying, so this is going to end up being 5 to the negative 2, that we're going to bring that negative exponent now down to the denominator, and it becomes 5 to the 2nd, which is 1 over 25. And here again, 1 stays in the numerator. Oh, so we're not moving anything here because we follow this rule. Negative times negative is going to give me a positive 12. So we don't have a fraction here. Now remember, this is over 1, but we don't write that. So a good point. Multiplying exponents, we use the signs of unlike signs being negative, but like signs being positive. Okay. Now as we do example 2, we need to keep in mind that by this 5, there's a 1. So this is going to become 5. 1 times 3 is to the 3rd. X to the 6th. And I do want us to simplify. So 5 to the 3rd is 125. X to the 6th. Now again, there's a 1 there in a sense. So this will be 2 to the 3rd. 3 to the 3rd. This is going to be 8. And 3 to the 3rd is 27. Now remember, there's a 1 there. So this is 3 to the 2nd, which we can now just write as a 9. P to the 8th, 4 times 2. Q, 5 times 2, the 10th. Okay, we see some of the work there, and then we'll do these, and we won't see the work till the other page. So as we do D and E, let's do D first. We may have to do some preliminary stuff. This is going to be 2. Now negative 3 times negative 2 is a positive 6. And this is y to the first times negative 2 will be y to the negative 2. We have to simplify this. 2 to the 6th power is 30. Let me check that. 64 is better. 2 to the 6th is 64. 2 to the 5th is 32. And then this will become up to the numerator as we move our exponent across the division bar. Okay. Now for this one, again, you could do it intermediate, or you can actually put things where they're going to be. So this is going to be x. Negative 5 times 7 is a negative 35. So that's going to end up in the denominator here. This is going to be y to the 14th. And this is going to be z to the negative 7, which will then go to the denominator as a positive 7. Now you could have written it out in an intermediate step, or just go keeping in mind if it's negative, it goes to the denominator. If it's positive, it stays in the numerator. Okay. And there's the work in your textbook. So, for Objective 2, they are bringing all of our rules together here. And if I were a student, I would want to have that written somewhere in my notes. And maybe even on a little index card. Looks like an index card here, where they give all the rules we've talked about. And they keep adding these qualifiers that your denominator cannot be a 0. Or in some cases, the base itself cannot be a 0. Okay, so we're going to get some mixed practice now in example 3. Now in 3a, we've set it up here. Again, we might say, what is x to the 0 power? Well, this is a 1. So we can actually take that out of there. That's just a 1. That makes it a little easier. And now what do we have? Well, we have, there's a 1 there, remember. 2 to the negative 2, you might remember, goes to the denominator as 2 to the 2nd, which is 4. And negative 3 times negative 2 makes this a positive 6. And that's our answer. Now for letter B, and there are a couple of ways to do this, but I would suggest simplifying what's inside the parenthesis. So this is going to end up being, as I bring this negative 2 up, a positive 2. So this is going to be left in my numerator now, x to the negative 3 to the negative 3rd. Here we're going to multiply. This is going to give me x to the 9th. Now the book goes over it too. Hopefully my explanation is a little bit more concise and you're following it as we do each item. Now example 3, or C here, this is a good one to use this other technique of whenever you have a fraction with a negative exponent, you can make that a positive exponent just by flipping what you have in the parentheses. That is, taking the reciprocal. So that's the reciprocal, and now it becomes a positive 2. So 7 squared is 49. 2 squared is 4. That's another way to do it. Now you could have, done it this way. This would be 2 to the negative 2, 7 to the negative 2, move them around. But the easier way is if you have a fraction to a negative exponent, just flip them. Your exponent is positive then, and you expand. In example B, as we look at it, we can do some simplification. Now, 5 to the negative 2 is going to go down as 5 squared, which will be 25 in our denominator. Now, we have x to the 2nd already down there. I'm going to move this negative 3 down, add it now to the 2, and I get x to the 5th. As we cross the division bar, the sign of the exponent changes. So this will become a positive 3, and 2 is 5. Now I'm going to bring my y up as a negative 5th, add it to 11, I get y to the 16th. Crossing this division bar, the negative 5 exponent becomes a positive 5. 5 plus 11, 16. Okay, and the book gives its explanation, and we got the same answers, didn't we? Okay, let's go on to example 4 and set those up. Now you could flip this if you like, take the reciprocal of this. Now the signs don't change, this goes to the top, this goes to the bottom, but then this would be a positive. Or, as the text is showing, you're going to simplify this a little bit. So this is going to be 3x squared. Take your y to the negative 9, bring it up, and that'll give you y to, there's a 1 plus 9 is 10, over c. Now that it's in this form, I would then flip it. I'd get z over 3x squared y to the 10th to the 2nd power. And now that this is positive, I get c to the 2nd. 3 to the 2nd is 9. This is going to be x to the 4th, y to the 20th. And that's what they got there too. Okay, they did it a little differently, but again, there's a number of ways to do it. I like this idea is if you have a fraction, you can flip it, take the reciprocal, and then our exponent is positive. That might be easier to work with. So I copied b over here, but notice I fiddled with this a little bit, writing my -1 by each. And again, that's okay to do. So as we expand this, we get 3 to the third is 27. And this will be a to the second times 3, a to the sixth. And then 2 to the third is 8. Now, this is going to be x to the -3, but I'm just going to move right up there as x to the third. So in the denominator, it was x to the -3. I'm saving a step by moving it up there. Now here I have x to the -3 times a -1, so this just gives me x to the +3 now. Now, this 4 to the -1 is going to bring this 4 up there. X to the -1, or I should say 4 to the -1, just brings the 4 up there. And then now a to the -2 times -1 gives me a to the second. Now, I'm going to get rid of this extra dot here because you only put that there if there's some confusion. There isn't any, or shouldn't be. Okay, so what do we do now? Well, we can do some canceling or subtracting or whatever's needed. 4 goes into there once. 4 goes into there twice. Now I'm going to take this a to the second and subtract it from this a to the sixth. So on the top I get 27 over 2. And now this is going to be a 2 from 6 is 4. And then x to the third, x to the third, x to the sixth. And lo and behold, that's what they have. So some of these take a little time. You may need intermediate steps, and there are different ways to do it. But again, what you know, what's comfortable, and what is right, of course. Well, as we look at example 5, we need to do what's in the parentheses first. So this will be x to the -b. This is going to be 2 squared, which is going to be a 4. We don't need that dot there, but it's going to be multiplying. And this is going to be x to the 2b. Reminds me of Hamlet a little bit. To be or not to be? Ah, yes. So now we have the same bases here. We have a -b and a 2b, so we just subtract now, and we're going to get 4x to the b as our answer. Little tricky, but following the rules. All right, let's write the other one out. So as we do this, we're raising a power to a power. We multiply exponents. So our top will end up being y to the 6a power. And our bottom is y to the a minus 6. So we're going to bring this up from the bottom and now subtract it. So that'll be a -a and a +6. So now in my numerator I have y to the 5a plus 6. And there it is. Now objective 3 is computing using scientific notation. Now since we have the textbook, we'll use it a little bit here. So the rule is we're going to multiply this by this. And that gives us 40.5. And then we're going to times this by this, and we just add exponents. So this will be times 10 to the negative 2. Now, they want us to write our results in scientific notation. You might say, oh, we are in scientific notation. There's a number and there's times powers of 10. And the answer is no, because this number is not between 1 and 10. So what we have to do there is move the decimal place over. So now we have 4.05 times 10, but we moved it over one place to the left, so we have to add one decimal place there, 1 power of 10, so this becomes negative 1. Now this is in scientific notation. Now for the next one, we're going to divide 3 into 1.2. And for that, we get a 0.4. Now we're going to take this, subtract that, and in the process of subtraction, we're taking that negative 2 up to the numerator. It becomes a positive 2, and we get times 10 to the 6th power. Ah, but is this in scientific notation? Looks like it, but this number is not between 1 and 10. So we have to move the decimal place over now one place. Moving it over one place to the right, we have to subtract 1 power of 10. And then this then becomes 4 times 10 to the 5th power. Now this is in scientific notation. So we'll be doing some practice as we do the mini lecture in a little while. And to wind this up, we'll take a look at this one. It says use scientific notation to simplify the results. So let's follow along. We're going to convert 2,000. Now my wife was asking me something here. All right, back to business. So we're going to convert this to scientific notation. So move it over 3 places. That's going to be 2 times 10 to the 3rd. This one I'm going to move over 1, 2, 3, 4, 5. So 2.1 times 10 to the negative 5. I'm going to multiply the 2 in this. I'm going to multiply this and this. And then I get 0.6 times, well, I guess I'm getting ahead here because I had to do the denominator also here. So the 700 is 7 times 10 to the 2nd. So when I brought that up, that was a negative 2 and negative 5 is negative 7. Positive 3 gave me my negative 4. And when I did this division, divided by 7, I get the 0.6. Okay. So now, this is not in scientific notation. So I have to move the decimal place over 1 this way, subtract 1 from that, and that gives me a negative 5 times 6. So there in scientific notation is the results of all of that. And I apologize for the distraction there we had. And now for some practice on our own.